Okay, hello everyone. We are live again. Gravity Max, second week, second live stream. So today we will be discussing science fiction technologies, and it's going to be really fun. Yeah. I've got my
Hey
friend.
everyone.
Hello. This is Gravity again. Yeah.
Back here.
Back
And I'm
again.
excited to talk about these technologies.
Yeah, this is pretty interesting. Some of these technologies are a little outside of modern physics, but we'll get into that. That's kind of the point. So, when do you think we should get started?
We give it a couple more seconds.
Okay, I'll check if there's anybody on the stream yet.
So while you're doing that, basically what we're going to do today is we're going to go across like many of the science fiction technologies that you see in media and in sci-fi movies and books and comic books, and we're just going to be diving deep into what these actually are, how realistic they are, and if we're ever going to get to see them in our lifetime or even in future generations.
Yeah, yeah, that's a very good description. That's pretty much what we're going to be doing today. And we have two viewers, and we have one making four comments. We've got our friend. He has made 4 comments. He was here last time. Thank you. We've got our first loyal viewer, you know? All right.
He's a what's your fans called?
A loyal... I don't know. I don't think there's a good...
A loyal fermion.
A loyal fermion? A loyal graviton. How about that?
There we go, a loyal graviton.
That's pretty good, I think. Okay.
That is pretty good.
Yeah. So I guess we'll get started.
Yeah, let's do it.
All right. Oh, jeez. So first is I got to plug my book that I'm making for November. Yeah, you can get it on Amazon. It'll be like early November. It would be great if I could get it November 1st. That's what I'm going to try for. But, you know, things tend to take time. So I'm not going to commit to November 1st. So just early November, I'll definitely make, like, when I make it live, like when I put it up on Amazon, I will mention that in the stream. So yeah, it's a science fiction book. It takes place 83 years in the future on the moon, and a lot of technologies that we discussed in last week's stream will come into play in this book. The other technologies that we'll be discussing today won't come into play in this book as much because I try to have my book more founded in science. So that's kind of a hard sci-fi book. That's what it's called. There's hard sci-fi and soft sci-fi. Soft sci-fi would be more like Star Wars, more fantastical elements in the book, but this is more science related. So you might even learn something from the book. So yeah. That was the obligatory book plug. So now we can
It's going to be a great story. It's going to be gripping, thrilling, and exhilarating.
Nice. I'll put that quote on the cover. Quote New York Times. Anyways, yeah. So let's today's live stream is on science fiction technologies, which we'll make a little definition for, I guess, because it's very important to define a topic. So this is basically technologies that could be possible if modern physics was a little bit different. So they don't, with modern understandings, they would violate physics, but there's a caveat to that we'll explain. Do you have anything else to say?
I'm ready to hop into some science fiction technologies.
Yeah. All right. Cool. So yeah, I'll move on to the next slide. Okay. So this is about the possibilities in special cases. So it might sound like weird to make a video about technologies that violate the laws of physics, because it's like, isn't this channel supposed to be about science? Well, we need to discuss that physics isn't necessarily all-encompassing. We haven't observed every possible case, and so there might be things that we just haven't seen yet that would alter our laws of physics. Now, an example of that is Newton's laws of physics, Newton's laws of gravity, did not take into account the speed of light, and then Einstein discovered that when objects are moving really fast or have really high masses, that relativistic effects come into play, and he changed physics by coming up with relativity. So you might end up with a new theory of physics, and we wouldn't know when it would come out, but it would come out in the light of discoveries of certain things we haven't observed yet and certain inconsistencies in physics. And that
we are going to discuss in this very live stream.
Yeah, and it might allow for some of these technologies to exist. Now, some examples of where we might find like oddities in the laws of physics would be inside of black holes. We like don't know what's going on in there. Physics just breaks down past the event horizon. We just cannot describe it. And another possibility is if we ever find a grand unified theory of like basically quantum mechanics and the standard model need to come together with relativity because they don't really work together, and if we could make a theory that connects the two of them, then that would also be a huge game changer.
Yeah, I was just about to mention that. How physics, being one of the most important sciences, actually does not have a unifying theory like biology or chemistry does. Biology's unifying theory would be evolution, and chemistry's unifying theory would be subatomic particles and the periodic table.
Mm-hmm.
And it's very interesting that physics is involved in both chemistry and biology, which have unifying theories, but physics in it of itself does not have one. And the discovery of this unifying theory might throw off or skew our perception of what we think about physics right now.
Yeah, that's true. It's actually really interesting. Chemistry actually takes into account relativistic effects somewhat. I don't really know a lot about this, but there's something called like relativistic like chemistry, like something like that. Relativistic quantum chemistry, I think. And it's just like really weird. I basically found it on a Wikipedia page because I was just like doing some research, like just fascinated by a few things, going down like a Wikipedia rabbit hole, and I clicked on the article that said relativistic quantum chemistry, and I'm like, nope. I am not going to dive into that. I know, right? I'm like, I don't have time for this right now. I cannot just dive into relativistic quantum chemistry. But it describes like the properties of the more massive elements are skewed by relativity or something, which is another example of special cases that these elements are pretty crazy, especially like the heavier ones. Like you get up to nihonium, flerovium, like they're just crazy, you know? They exist for fractions of a second and then they're just gone. So yeah, that's pretty much gives us a basis for a justification to talk about these technologies tonight, even though they are like kind of unrealistic. Yeah. So I'm going to go ahead to the next slide. So we start with a classic, faster than light travel. We've got the USS Enterprise here, and we've got a light beam, a wave of light, and it's outpacing it. So yeah, pretty basic graphic. And basically, faster than light travel comes from the fact that space is just so big. There's just so much empty space between like stuff that if you want to have a sci-fi show that isn't like 99.9% traveling, then you gotta like break the laws of physics a bit, you know? Yeah.
Yeah, the speed of light is thought to be the fastest thing in the universe, and that has yet to be disproven. Its current speed is 299,700,000 at 92,458 meters per second, which is incredibly fast. To put that into perspective, every day it goes 173 times the distance between Earth and the Sun, and it can get from the Sun to Earth in just 8.3 minutes.
Yeah.
So when the speed of light was discovered, and I remember a while ago they thought that this other particle might have been faster than the speed of light, but that was due to a calculation error.
Which particle was it?
I can't remember it, but I'll look for it. But
okay.
They did some test, and they got a reading that was incorrect, and that led them to believe that particle was faster than the speed of light, which would have, and it's interesting because just that event would have skewed our understanding of physics and astrophysics, even that small of like a particle.
Yeah, totally.
You would think that wouldn't have that much impact, but it really does, especially when we're calculating stuff like space travel or the distance between stars and many other very important things. So really, any discovery in physics contributes to our overall understanding of it, and it might even shift things so much, so exponentially bigger than it. It's very interesting. So I'm gonna look for the name of this particle.
Okay. Yeah, we're actually gonna talk about how even single particles going faster than light would allow for faster than light communication, which even if you couldn't travel faster than light but could communicate faster than light, that would be huge in its on its own, you know? But yeah, so faster than light travel, Einstein's relativity basically proved that you can't go any faster than light, because when you do, everything just kind of breaks down, because you've got time dilation that reaches 0 at light speed and then would become, it would just go crazy past, it's just undefined pretty much. You would have undefined time dilation if you went faster than light. So we would have no idea how your sense of time would end up. But if you could achieve faster than light travel and not, be blasted into the 6th century, then it would be pretty revolutionary. So we'll start with the warp drive, also known as the Alcubierre drive. And the warp drive is a classic concept from sci-fi. It's in, Starship Enterprise. And, oh shoot, it's just in a lot of, it's just everywhere, right?
I found the particle.
Oh, the particle, yeah. What was it called?
People thought that it was a neutrino that was actually faster than the speed of light. And for those of you who don't know, the dictionary definition of a neutrino is a neutral subatomic particle with a mass very close to 0.5 integral spin, rarely reacting with normal matter. So there was an experiment where they effectively raced a neutrino and light, and a neutrino, the results were that the neutrino won, but it was actually because their instruments were faulty, and that light had actually edged out in front of the neutrino. So I just wanted to bring that up because it's a detail that's interesting to me, because that would blow away one of Albert Einstein's claims that light is the fastest thing in the universe. Yeah. And from that, we would be able to do experiments on neutrinos, and if they were indeed faster, but we would be able to use neutrinos in our technology. Yeah. Just like how we use light in our technology. Yeah. That's very interesting to me. Also, our friend in the stream wants you to look at chat to connect to viewers.
Oh, okay. I'll look at the chat. Oh my gosh. Okay. Wow. Let's see. Science and I guarantee I will be there to get the. Oh, thank you. I guarantee I will be there to get the first book. Nice. Okay, yeah, I'll read the chat. First light beam. Okay.
Light beam.
Oh, we have 3 viewers now. That's pretty cool.
That's because I turned on the stream.
Oh, okay. Okay, makes sense. Yeah, well, thank you for your commenting, commentator that, don't want to expose the identity of. Yeah. But yeah, thank you for watching our stream. We'll be doing it every week. And so, yeah, it's fun. Maybe we can,
Anyways,
yeah, eventually we're going to have more people on and stuff,
Yeah.
So, yeah, that'll be pretty cool.
Alright, back to the warp drive.
Yeah.
Now, you hear this, like, everywhere in lots of sci-fi situations,
Mhm.
like Max said, and with, like, if you've ever watched Star Trek, they always say, we're going to warp 5, right? Which is, like, the speed limit in that show. I can't tell you why, but they always go, like, like, warp something. And that warp is the speed of light. So if they were going like warp 5, I believe that's like almost like Mach 5.
Oh, okay.
How it kind of operates on that scale. So these are incredibly useful for sci-fi authors because, like you said, there's so much space. Like there's so heavenly bodies and stars and galaxies are so distant from each other that the only way to have a book that isn't all just traveling from point A to point B would be to almost warp in some way. And a lot of this live stream is going to be talking about how we can bridge that distance and shorten it.
Yeah.
And this going fast is one of the first ways we tackle this issue, but you're going to see that there are many other solutions to this issue.
Yeah. Yeah, so basically, this is the warp drive, and the name Alcubierre drive comes from this scientist, I think in like the 90s, I think like 1996, this scientist wrote named Alcubierre, wrote a paper that would like mathematically, like on a hypothetical way that you could achieve a warp drive, and since he like formalized it, he had his name attached to it.
Of course.
Yeah, and basically, his like formula would require negative mass to create a warp drive, which we don't have. So while he did make a theoretical way that you could just build a warp drive, it required negative mass, which is just like, like a non-starter, Also, it required a lot of negative mass. I think it was like the negative mass equivalent to the positive mass of Jupiter. But I think future people like shrunk that value. But yeah, either way, any amount of negative mass, like 1 proton of negative mass, just not possible,
So I got interested and I looked at the warp factors. And warp 5 is actually like it doesn't function on the same scale that Mach does. Warp 5 is actually 213 times the speed of light, and warp 3 is 39 times. Warp 2 is 10 times, and warp 1 is just the speed of light.
So it's like logarithmic, somewhat.
To some degree, yes. I'm not sure what.
Yeah.
Really, I'm not sure if like they put actual math behind it. I wouldn't be surprised if they did, because in lots of like hard sci-fi shows, like an incredible amount of math goes into it.
Yeah.
And personally, for me, that makes it makes the story more attractive.
Yeah, totally.
When you put that math into it, which I'm sure a Truly Dead Rock has tons of math in it. Gotta plug the book.
Yeah.
It makes the story more real because it's based on our real life math and our real life physics.
Yeah. Yeah, totally. I think Futurama, this like show about like the future, it was a comedy show, but they had like physicists on the staff, on the writing staff, which is just pretty nice when you have that level of like dedication to make something like accurate. But yeah, so basically, one last thing about warp drives, then we'll move into how they'll affect society, is that warp drives function by expanding space behind them and contracting it in front of them, which is what you can see from this graphic here of like this nice linear grid getting warped, which I guess is the name warp drive. So the space in front of you gets smaller so you can move through it faster, and the space behind you gets larger, which like propels you forwards, and your little bubble of space can move faster than light, but you yourself within your bubble of space are not moving faster than light. So it's like a little cheat, you know? But yeah, so basically a warp drive would let you move between two places a lot faster than you could in real life, which is just revolutionary. Even within the solar system, it would allow you to connect the solar system a lot better because, well, basically it's like for travel through the solar system, if you're using humans like to travel instead of just robots, then you have a limit on like to get from Pluto to the sun to the other side of Pluto's orbit. The minimum amount of time it could take would be 25 days because that would require 10 meters a second of acceleration towards the sun and then 10 meters a second of deceleration, which is the only way to travel with people. But then technology, if your mind is on a computer, then you can be sent as a string of code across the solar system, and that same distance can be covered, I believe, in like half a day, I think, which is still quite a while if you think about it. So then a warp drive would allow you to just like take a nice little road trip pretty much, like just pop over to Venus, like just a 30-minute warp from here, you know, to visit family or something, and it would basically just allow trade to become a lot more like effective and allow the solar system to become more interconnected. And then also it has effects on interstellar travel, which would basically be the time it takes to get to the nearest star is 4.2 years at the speed of light, which you'd need to do a little less than that just because of physics. But if you had a warp drive, then you could actually go there in a shorter amount of time, depending on how fast your warp drive was. And so do you want to talk about the societal effects that this would have?
Yeah, sure.
Okay.
So, with the warp drive, it obviously makes transportation just that much like faster. And if you remember from our last stream, we were talking about how humans would start lunar colonies, and then after lunar colonies, they start Martian colonies, and after that, they start Venusian colonies, and then from there, like vastly into the future, we might even like populate some percentage of like the entire Milky Way galaxy if we find enough M planets. But finding those M planets in the first place would be greatly aided by a warp drive because NASA has theories on planets that could support life, and but they're pretty much just that. They're just like theories because they look at the conditions that those planets are in, and they can't really be sure unless they like shoot a probe at it. And all of these hypothetical habitable planets are so many light years away from us, it'd be like ridiculous to even venture out that far.
Yeah.
But with a warp drive, if you simply even just had a probe with a warp drive going whatever factor of the speed of light, you could instantly transport it to that hypothetical M planet and look and like probe the planet to see if it could indeed support life, which speeds up human colonization of space just that much more.
Yeah.
And when you eventually do colonize that habitable planet, if you need to get back to Earth, let's say you like left your oven on at Earth, it wouldn't take you like 500,000 light years to get back to Earth. It would just take you like 2 or 3 minutes going some factor of the speed of light with a warp drive. So I was messing around and I was doing calculations over here, and I wanted to see how quickly you could get from Earth to the edge of the Milky Way galaxy using a warp drive.
It's something like 25,000 light years, right?
Yeah, exactly. So going warp 5, you could make it from Earth to the edge of the Milky Way galaxy in 117 years. Let me check what warp 8 would be. Warp 8 is 1,024 times the speed of light.
Okay.
Which is an insane number. So 24 years going warp 8. A distance that would usually take with our current space shuttles, what's the average speed of like a space shuttle? Like how fast is Voyager going?
Voyager, I'm not sure how fast. Let's see. It would take it like 20,000 years to go the 4 light years to Alpha Centauri, so I guess that would be like
Voyager
1/5000th the speed of light, you know?
Yeah, Voyager is going 38,610 miles per hour. So suffice it to say, it would take a while. To go that same distance.
Okay. So it would take a while. So in effect, this would have the warp drive is that it would allow like countries or empires or whatever they're called in the future to spread across a more vast distance. Because we didn't talk about this last time, but if you think about interstellar travel, and you think just the nearest star, Alpha Centauri, is 4.2 light years away, right? So if you want to govern a place that it takes you 4 years to get to, it'll be a little difficult, because say that your Alpha Centaurian colony decides to declare independence, right? And they're just like, they're done, right? The message that they've declared independence would take 4 years to get back to Sol, right? Or to like the solar system. And then it would take you at least 4 years to send troops there to potentially fight the battle. And then if those troops need reinforcements, it would take another 4 years for them to get there. So there's really no way to keep a place like in line other than maybe trade, but that's iffy, you know, that's a little difficult. But with a warp drive, then if they declare independence, that would get back to you very quickly, few days, I don't know, depending on how fast the warp drive is, and you would be on their doorstep like very quickly. I think that's probably the main effect. It would, depending on the speed of the warp drive, the faster the warp drive, the more that your interstellar empire could be cohesive. So, let's see. Yeah, it's just warp drives would be like very they would just change everything. Yeah. Do you have anything else to add?
Not really. It's just that it's interesting how currently countries are like fighting over what would then seem like incredibly small spaces of land.
True.
When countries today would, with this technology, claim like entire planets.
Yeah.
And that entire planet would be like of that race if they colonize it, of that country's race.
Yeah.
And I think it's almost comedic and almost ironic in some way how all of these countries that could one day control entire solar systems are now fighting over one planet.
Yeah, that's true.
And it's not even that good of a planet.
Yeah, it really broadens your perspective.
Yeah.
Definitely. So I'm going to go to the next slide.
Yeah.
So here we've got teleportation. Teleportation is pretty much just instantaneous travel to wherever you want to go. So whereas warp drives are still take time, even though it's a much shorter time, teleportation is just boom, you're there, which is even better. It just more exacerbates the effects on society that you would see earlier. Because if you could just teleport anywhere in the universe, then you could control other galaxies. You could keep that under your domain. Because even if they declare independence all the way in Andromeda, which is 2 million light years away, you could pop over there in an instant with teleportation, which is just really, really crazy. Because even 2 million light years for most warp drives, at the different warp speeds that you were saying, that would be a super long time, right?
Yeah.
But with teleportation, it would be instant. Which is another interesting effect, is that space and physical location would just no longer matter if you think about it. If you can just teleport from point to point, then say your town's bank, right? You might just teleport there instead of driving or walking there just because it's that much easier. But then you might also just teleport to the Andromeda galaxy to visit your relatives. And it would just be the same amount of time. It just makes space just irrelevant, kind of,
Yeah.
And another,
Yeah, go ahead.
Okay. Basically, with faster than light travel, what it allows you to do is it changes society more from terraformation to just finding a good place. Because societies might get pickier if they're able to go farther in shorter amount of time, because if it takes you 4 years to get to a star system and the planet is pretty mediocre, I mean, you're just gonna live with it, you're gonna even if you have to just mine out the planet for its materials, just destroy the planet, mine it up, and turn it into space stations that are rotating with centrifugal force for gravity. Even if you have to do that, that's better than going another 4 years just to the next star system, But with teleportation and with warp drives, it allows a society to be more picky and say, you know what? I don't need to choose this planet. I can just go over to the next star system, which might just be an hour or an instant away, and just find a better one,
Yes.
Yeah.
What I was going to say is that this does raise some...
yeah.
Of if teleporting, kills you and then makes an exact clone with, all of your memories, or if it, does something else.
Mm-hmm.
But, I think it would be very interesting, because I would bet my money on that if this technology came out, if teleportation came out, some people would kind of boycott it and be anti-teleporters.
Oh yeah, totally.
And
yeah.
Because this technology is almost so advanced, it can almost be to a frightening degree how much we don't understand it. And that's of course speaking in 2019, where we don't have teleportation.
Yeah.
But I think it's interesting to see people's response to all of these technologies, and if what we talked about in our last live stream, the technological singularity, where technology is at the point where it can keep improving itself, on a machine scale that just keeps getting faster and faster,
Uh-huh.
we could realistically have this like technology if they like kept working towards it and just delving into sciences that I can't even like begin to say the name of.
Yeah.
And it's just interesting to see how each event would lead to the different technologies.
Yeah, like you would totally get like groups of like anti-porters, right? That would drive their kids to school instead of letting them teleport. And they might form like groups on Facebook. you know.
But to some extent, like there's the conversation of like, are they right?
Yeah, exactly.
If this technology is indeed killing you and then making an exact clone of you, is that unethical?
Yeah,
is it ethical to even teleport?
Yeah, it's really interesting because medically, assuming it's like not teleportation that gives you like instant cancer, assuming it's just fine, right? Like no radiation, no nothing, then like medical experts would be like, yeah, this is fine. But yeah, it would be interesting to see the dilemma. It's like the ship of Theseus problem, I think, where if you have a ship and over the years it like wears down and you give it replacement parts like periodically, eventually it's all new parts. So is it still the original ship, the ship of Theseus, or is it like this new like fake ship? And when you have teleportation, it's kind of like that's happening in an instant instead of over many years. And so that factor of time kind of makes people a little more wary of teleportation because if you think about it, all of the cells and all of the like atoms in your body are replaced like every 7 years. So anyone that would be against teleportation would also have to kind of reconcile with the fact that like, like every 7 years I am pretty much killed because
I'm looking forward to it. So
yeah.
Let's get the TSA.
Yeah, I know. Oh my gosh. Yeah, it's really sad how like air travel has become miserable. It's like air travel is like a miracle of like science and it's become miserable and I'm reluctant to see how societies dealing with teleportation will make it miserable. Hopefully it won't do that.
But that does raise another concern of a security concern.
Yeah, that is true.
There's nothing saying that I can't like grab a gun and then teleport into like a top secret facility.
Yeah, it depends on how the teleportation works. If it's teleportation where you have to set up like a teleportation like booth, right? If you have to set up like a designated like room or like closet that you can teleport into and out of, and you have this sort of patch like network, then the security risk would be a little less. But if you can just teleport into any empty space, then it's just like, there's no way to be secure with that. But I guess it is true with technological immortality. As long as you have like 20 backups of your mind just on computers that have been chucked into the void, like no one will know where those are. So that would probably be the security response, I think. Especially in a society that accepts teleportation, having backups of your mind wouldn't be as much of an ethical issue like the ship of Theseus thing.
Yeah.
So yeah, it's interesting. It would be a security risk.
Alright, let's go on to the next thing.
Alright.
Wormhole.
Yeah. So we've got a nice...
Very interesting topic.
Yeah. We've got a nice Minecraft nether portal here. Wormholes, they would be pretty cool technology, not just for transportation, but for architecture as well. So for transportation, you pretty much have the same effects as teleportation, except this would be like the kind of teleportation that's like booth to booth, not booth to open air. Unless you can just open portals at will, then yeah. So depending on what type wormholes are pretty much just a type of teleportation, I'd say, but their effects on architecture and just the way you might live your day-to-day life, I think, are really interesting. Um, so yeah, I have a few concepts. Do you have anything to say before I get started with this?
On wormholes?
Yeah.
Um, no, I think I'm ready to hear what you got for this.
Okay. So, say that you live in both New York and Florida, right? Like say you're like one of those snowbird people that go down for the summer and stay up in the winter, right? You could just have a single house, right? Where instead of one door in the house, instead of connecting to a closet, it would connect to a closet door in the other house. And then you could just instantly travel back and forth between these two locations, and your house could be a sort of contiguous piece of architecture. Like it would be a continuous volume of space. It would be like you left your keys in your kitchen in New York, and you just pop over through your door, and then you can just come back, and it would be really interesting. So, and it doesn't even have to just be a door, right? Say you just had it in the middle of a corridor, made it seamless with the wall. You could instantly be in a different place just by walking past an arbitrary line that's you didn't know about. And for space travel, this would be interesting too, because you could have different rooms of your house on different planets. And so they would have different gravitational pulls on them. And so imagine you had a corridor with a couple of portals interspaced down it, where the room starts on Earth, then it goes to Mars, then the moon, and then just space. You would have this sort of transition to zero gravity just in your own home, which is just really peculiar and just interesting, and an aspect of portals that are not often discussed. They're more discussed for transportation. And now another possibility is you could sort of make a perpetual motion machine by just dropping an object between two portals, and just letting it fall forever, which we'll talk about more later about perpetual motion machines, but you could make one using portals. And with portals, it allows you to get from the ground into orbit just instantly, obviously, because you just walk through a door and then you're in space. And it also allows you to say place things in impossible manners. So you could have an object that is more than 360 degrees around. Because say you had 4 interconnected rooms, right, just connected by normal doors, right? But then the 4th room connects to another complex of 4 rooms like that. You could go around 8 square rooms, 720 degrees, before getting back to your own location, which would be kind of like a Mobius strip, except in 3 dimensions. So you can make impossible shapes. You could also make shapes that are larger on the inside than the outside. So say you have a job in New York and you don't want to deal with the commute, right? You could buy the tiniest bare minimum apartment in New York, but then actually live lavishly because you have a place out in the countryside that is connected by a portal into, say, the back of your apartment, and then you're just there. And so you have this sort of continuous space for living. So that would be really interesting. And then I'm trying to think. Also, with gravity and stuff, is that if you have one portal facing down and one is facing sideways, then if you reach through the downward facing portal into a downward field of gravity, it would transition into a sideways field of gravity instantly, which would be really weird. You could have 2 rooms on top of each other where they're connected by their ceilings and they're upside down, like in Inception or something with the buildings. And you could just come up with crazy wacky designs of just building things with portals. It would just be craziness,
Yeah.
Yeah, like you just have to ignore all laws of geometry. Like geometry just goes out the window with portals. Um, yeah. So that's my piece. What do you think?
Wormholes. Definitely like 8 out of 10.
Yeah.
Easy. 8
Yeah.
out of 10.
Nice.
The societal impact of them, I think you nailed it. It was like if you have a house in like California and one in New York, you can just go like in between them.
Yeah.
But again, kind of like teleportation, this could also be a risk because if you have like a criminal like fleeing the police and then he just runs home, goes through his wormhole, that handy dandy just spits him out on the other side of the country, then he just shuts down his wormhole.
Yeah.
He's now escaped pursuit.
Exactly.
So again, there's the legal aspect, and it's kind of funny to try and like predict what the judicial system will do about wormhole technology. But I think that a lot of this technology we're talking about could easily be abused, and there's the point that any technology ever can be abused.
Yeah.
But I think just this specifically, because it's on such a different magnitude, because it literally transcends the laws of space and time.
Yeah, exactly. Yeah. Well, how do you think it'll affect the judicial system?
Well, I just mean that, like, if they, I'm trying to think of, like, some special cases that would occur.
Oh, yeah, wait, I have an idea. Like, say, you know how it's a defense of, like, if you're accused of a crime, and then, like, a crime that occurred in, say, New York, and you're like, I was in California then, like, boom, just case thrown out, right? Because it's impossible to get between New York and California in, like, less than 6 hours. But in a world where it is possible, your alibis would need to be, like, more specific. Like, you would need to have, like, a picture or something of yourself there, like, right at the time of the crime. Otherwise, it could have been, like, it could have taken you 5 seconds to just pop over and commit the crime, you know?
Yeah.
Yeah. So then another interesting thing about wormholes I forgot to mention is that wormholes would allow you to travel through time, but only forwards through time and like back to when the portal was first created. Now, the basic premise is time dilation, just under Einstein's theories of relativity. Say you had one end of a portal fly at near light speeds around like the Earth, or just you just had it somewhere where it experienced a lot of time dilation, and you brought it back 1 year later, right? So it's been gone for a year, but the portal, because of time dilation, only thinks, say, 1 day has passed. When the portal comes back, it isn't connected, like when it comes back 1 year later, it isn't connected to the other end of the portal in the present. It's connected to the other end of the portal 1 day after it left for its like time dilation sabbatical. So you could go back in time a year through this portal and like be back in the past, and then you could jump through it again and bring yourself back to the future, and you could just instantly have time travel because of wormholes.
Yeah. Which is a perfect segue.
Oh yeah, into time travel. But first, I will check the chat. I'll do it after each point. I'll just check the chat. Okay, let's see. Okay, not much more, but our friend's still here. We've got 2 concurrent viewers, so that's fun. Yeah. Thank you guys for hanging on, oh my gosh. Wouldn't that be, like, so sad if it was just the 2 of us? We were the 2.
There's people watching in the future.
Ah.
Which brings us
that's
to
true.
Our next point.
That's true. Time travel. Yeah.
The segues are unreal today.
Yeah, exactly.
So, time travel, you've heard of it, you've seen it, hopefully you haven't done it, but what it is moving either forwards or backwards along the 4th spatial dimension. So going forwards in time does not provide as much of an issue as it does for moving backwards, because
Yeah.
when you go backwards in time, you experience what's known as paradoxes. And paradoxes are kind of impossible flows of logic. The most famous one being the grandfather paradox, which is where if you go back in time and you kill your grandfather before he has time to create your dad or you, or really just your dad, before he has time to do that, then you're effectively like killing yourself. But if you're dead before you're born, then you couldn't have gone back and killed your own grandfather.
Yeah.
And it's paradoxes like those. There's also certain information paradoxes, such as if you learn Spanish fluently, like you go and you take course after course of Spanish, you can then speak Spanish fluently, and then you go back in time to when you first started learning Spanish, and you teach yourself Spanish, like all in those years, so you never take those courses, so you yourself would never have been able to know all that Spanish.
Yeah.
You know?
Yeah. Yeah. It's interesting. Time travel into the future is like already possible, just under known physics. It's just time dilation, because if you experience heavy time dilation at like near relativistic speeds, then you could be gone for one day and come back a year, 10 years, a century into the future, and like that's just fine. But yeah, time travel into the past, just a huge problem. And the problems, like all the paradoxes, they pretty much arise from this fact that like you can't affect your own starting conditions, which is basically, it means that at the moment you go back in time, whatever you do in the past can't change the state of being of like the state of the world like when you left. So say like you left at 8:37 a.m., like you were a little bit hungry, you had like half a bowl of cereal for breakfast, and you were a little thirsty, right? Whatever you do in the past needs to have that same, like it needs to allow that to happen again. Otherwise, the train needs to arrive early and like have a disgruntled businessman miss his like train. Like things need to be exactly the same. Otherwise, you yourself might be different going back into the past, which would cause slight like idiosyncrasies and just slight changes that would just completely cause paradoxes. And so
Yeah.
So I'm gonna. Oh yeah.
Yeah. Go ahead.
I'm gonna move to the single timeline.
That's what I was going to
Okay.
do. I was going to say that these paradoxes all take place under the assumption that there's only one timeline. Time is singular and linear.
Yeah.
This has been heavily debated because there's really no real way to prove this, and for, later on we're going to talk about some extreme physics and how they could possibly be used to solve this conundrum. But basically, all these paradoxes that we're talking about occur on this idea of the single timeline, how there's only like one path to go on.
Yeah.
And if you go back in time and you alter something, that breaks down the entire timeline. And that sparked the idea that causing a paradox will like rip the universe in half, or just cause it to go out of existence because of that information loop.
Yeah. Yeah, basically it's like when you think of time has always been a single timeline. Like in any history class you've ever taken, it's always been an event on a timeline. Like it's very hard. There are possibilities, this is for the next slide, that time might have alternate paths, but the traditional concept of time is just a single, like, four-dimensional shape, right? And the problem is that when you bring time travel into that, it's kind of an issue with determinism and free will, is that if time is a four-dimensional shape, then it has to already exist. Like the future must already exist somewhere down the line of this alternative of this like shape. And like you know how if you could measure the exact state of every particle in the universe, you would supposedly be able to predict the future, right?
Yes.
Yeah, but like that's impossible because of quantum mechanics, which we'll talk about later. But if you could do that, you would be able to predict the future. And when you time travel, it just messes things up because if there's only one timeline, either time needs to have some sort of immune system or some sort of like force that like thwarts any time traveler's efforts and makes it impossible for them to change time in any way, or time needs to be extremely feeble, and the first time someone time travels, just the universe will implode, you know? Um, which also makes it possible that time travel is impossible. That might be the defense mechanism, but it might be that like as soon as you go back in time, whatever you do um, to like change things will be thwarted by just happenstance. It's kind of like the book 11/22/63 by Stephen King, where like a man goes back in time to try and prevent the like whatever, you know, constant.
Yeah.
Yeah. So single timeline, it's kind of restrictive. Single timeline basically kind of makes time travel impossible. It just makes it riddled with paradoxes, and it's just like a huge pain. But most science fiction stories that involve time travel operate on a single timeline principle, but then they break the laws of the single timeline principle anyways. Like if you think of Back to the Future, um, Marty goes back in time, and because he makes it so that his parents like never fall in love, he like starts fading from existence. Which you think, okay, that might be a single timeline thing, even though that's like a paradox too. But you think, okay, it's a single timeline, and these are the effects of a single timeline. But then when he gets back to the present is entirely different, and he's surprised by the present being different, which shouldn't happen because basically it's like his family's like richer and like cooler, right, when he gets back, and he's surprised by this. But what really should have happened is that he should have still faded out of existence and been replaced by a version of himself that was cooler and richer and like knew like the life of this family instead of just coming back from the other timeline, which like that suggests a multiverse thing. So most
which leads us into our next slide.
Yeah, that's our next slide. But basically the message is that most time travel stories are inconsistent.
Yeah.
So shoot, there we go. Okay, my slides are lagging. Anyways,
Right. So
multiverse.
The multiverse. You've heard of it. You probably haven't seen it, and you can't really experience it unless that's what we're living in right now. You might have. The example that comes first to my mind, just because I love comic books, is the DC and Marvel multiverses. In these, they have, specifically in the DC ones, if you've read the comics or watched The Flash recently, they've been delving into alternate Earths. And this is probably one of the best ways to think about the multiverse, because on all of those alternate Earths, those are different realities almost, different versions of Earth, because something has changed in the timeline. And this is also a solution to many of the paradoxes that we were talking about in the earlier slide. How it solves this is just that it will, like, every time you cause a paradox, it'll just divert you to a different Earth where that paradox is like explained because the time has changed. So the entirety of that Earth that you're on has changed, and you've been moved to a different reality of Earth almost.
Yeah. Yeah, one way a multiverse could work in reference to time travel is I kind of want to use this in some stories in the future, but basically what happens is that the act of traveling to the past causes time to split. Even if you go back in time, just appear for a second and then just go back to the future, what you end up having is one timeline where everything runs normally, and one where you appear for a second and disappear. And so this pretty much fixes all of the paradoxes because it basically says if you go back in time and change things, you aren't changing your own starting conditions. Like you're not affecting your own past, you're affecting a different past and creating a different future. So like there are no issues for you, right? But the only concerning thing about a multiverse is that, say you go back in time, change some sort of event in history that you don't like, right? Just change it to make it better, and then you go to the future of that timeline, there's going to be an alternate version of you there already. So unless you want to like duke it out with your clone, like you're going to have to leave and go back to your original reality that like you don't like. So a possibility to fix this would be, along with changing history, you would also have to make it so that you were never born, which the ethics are shady on that. And then you could hop into the future and live there. But again, that would have the issue of you wouldn't have an identity there because you wouldn't be like a person that existed. So the multiverse, it fixes it. It like allows the physics and the logic to calm down a bit, but it would still be quite pesky, you know?
Yeah.
Yeah.
And I definitely think that using this in a book would be like a very interesting topic.
Yeah.
Because this topic has usually or most famously been used in comic books such as like DC and Marvel.
Uh-huh.
And it's also just a great platform for stories in general because DC has all of these like spin-off stories, and then at the end they're like, and it all happened on Earth 263.
Yeah.
Right? It's pretty interesting because now I'm not going to start an entire comic spiel, but what I'm going to say is that it's interesting to think that this could be our actual reality. That if this multiverse is true and we do live in a multiverse, then there's like realities that are like changed and altered in some way, and if it really is an infinite multiverse, then every possibility exists.
Yeah.
You know, and that's crazy to think about. Like if that's the case, then there's a universe in which like you, the listener, are creating this very live stream. And
wow.
Me and Graffy Max are listening to you talk about the multiverse.
Yeah.
And it's crazy to think about. And if you were to go to that Earth where you, the viewer, were creating this slideshow and this live stream, and we were listening to you, they wouldn't think that anything is amiss because it's their reality.
Exactly.
And they're rooted in that.
Yeah.
So it's almost mind-boggling to think about.
Yeah, maybe ours is the weird reality.
Yeah. Who's
maybe
to say that?
Yeah.
Maybe in one reality, I have the channel with 509 subscribers.
Yeah, exactly. Yeah.
As of now.
Yeah.
But,
yeah, that's really it's true. And so another impact of this, like, we like to talk about like impacts on society that these technologies might have. And basically, for the multiverse, I think the main impact on society would be that you would instantly be able to gather up a perfect record of history. So any historical event that's like kind of like wishy-washy, like you don't really know exactly what happened, like, you know, any conspiracy theory, right? You could just send a camera back in time, not worry about any paradoxes, film some video of the event, and find out, oh, so that's what happened. And so very quickly, especially if this technology becomes cheap. And that's the trend. Whenever a technology like gets out there, it starts off with like just being a very elite thing, but then everyone slowly gets it, right? So you would have just amateurs pretty much sending like a GoPro back to like those British like princes, I think, that were like killed by their uncle or whatever, and it's like shrouded in mystery. Just send a camera there, like see what happened, and then you'd like clear up all historical misconceptions, and you just know what would happen. And it could be shot in like ultra 4K HD, right? So yeah, so that's a big impact on society. Like that is definitely big. Especially, it would affect the judicial system too. Like you said, is that if there was a crime that was committed, all you have to do is go back to the time when the crime was like reported to have happened, and then put a camera there, and bam, you know exactly what went on. Like instant replay. And yeah, so that would be interesting. And also, especially with biological or technological immortality, you could get people that would like vacation in the past. Like, you know, the like I was born in the wrong generation types. You know those people? They could just like, you know, go back in time and enjoy themselves in the past. Like, yeah. And for like, the best thing about time travel is that you could go back in time for 30 years and then show back up like 1 second later from when you left. So you could have like huge like sabbaticals, like vacations. And if you had biological or technological immortality, you could just vacation in the past for like hundreds of years and then come back like a second later and just go about your life, you know?
Yeah.
So yeah, it's a very interesting technology. You could also say like go back in time to start. You could go back in time to like cause a reality split, and then go to the future of that reality, see what technologies they create, and then just use them in your own. So like no one would really have to invent anything. You would just have it. Yeah. Anything you have? Anything you want to add?
Honestly, it's just fun to think about all the different things you could do.
Yeah.
Because, like you said, it makes time travel like that much safer. Because you know that you won't rip the universe in half.
Yeah.
Because honestly, there's like more than one universe in a multiverse.
Yeah.
But it's also exciting to think about all the different realities, and it's kind of a sort of Fermi's paradox, where it's like one of these realities should be advanced enough to contact all of the other ones. So until we get that contact, we can't really be sure that this even exists.
Yeah, it's true, but it's also, you might think a solution to that paradox might be like, maybe our timeline is one that's being intentionally sheltered, right? Like, maybe someone started it by just like going back in time and slightly tweaking a historical event, like, I don't know, knocking an expensive vase off a table, like a cat or something, just knocking it on the floor, allowing a new timeline to be created where that vase is shattered, and just allow time to go slightly differently, see what technologies are created, and just harvest them for their own reality. And they might be telling like other forces like, keep out, like don't mess with our timeline, don't give them time travel capabilities, because then they won't invent anything for us. So that might be an answer. Yeah. Anything else?
I think that just about wraps up the multiverse and time travel.
All right. I'm going to check the chat now, because this is like, we're going to go to our next topic. Okay. Oh, yay. We have another commenter. We have...
He wants to subscribe twice.
Yay. Yui Films. Thank you, Yui Films. Yui Films, we might invite on, like, if he wants to join us. he can join us on a live stream if he wants, you know? I'll talk to him about that, though. Thank you for watching. If you're interested, yeah, we're, like, going to invite more people on in the future. Anyways, so our next topic...
Thermodynamics Breakers.
Thermodynamics Breakers. So you've got a nice image here of unlimited power with Emperor Palpatine in the bottom there. And you have a nice, like, bus bar plugged into itself. Yeah, so basically, the laws of thermodynamics. You love them, you hate them. Basically, like, energy cannot be created or destroyed, and entropy always rises in any closed system. So those are basic laws of physics, but they are pretty annoying and pretty, like, like morbid, because it basically, under thermodynamics, it's predicted that the universe will die of heat death, where everything just gets very spread apart and, like, the energy density is, like, uniform across the universe. So you just end up with a universe filled with just, like, photons and radio waves and just boring nothingness. And that is obviously not a desired outcome, because if humanity wants to continue into the future, it won't want to stop continuing, you know?
Yeah.
And the heat death is basically the ultimate problem for humanity, you know? Like, if we accomplish interstellar travel, we can outlive our own star. If we, like, develop nuclear fusion, or if we can use black holes for energy, then that keeps us safe for a while. But as soon as you are faced with the heat death and there's no usable energy, then it's just like, you're done. You can't do anything. So this is a really important topic, you know?
Yeah.
All right. So our first type of thermodynamic breaker is a reactionless drive. So reactionless drives would basically be drives that violate the law of conservation of momentum and just destroy the rocket equation. So the rocket equation basically says you have to calculate how fast your, like, rocket exhaust is moving out the back of your rocket ship, and how much, like, massive that exhaust is compared to your ship, and that can tell you your ship's maximum speed. So say your ship is, like, 10% like cargo and 90% fuel, which is actually a pretty common, like, ratio. In spaceflight, most of the mass of the rocket is fuel, which is pretty crazy to think about. But say your 90% fuel goes off at, like, I don't know, 10 kilometers a second behind you, right? Then you, the 10% of the mass, will be propelled at, like 90 kilometers per second maximum. I'm not sure if I'm doing that exactly right, but you get the gist, basically. It's that it's Newton's law, every action, I think it's the first law of motion, every action has an equal and opposite reaction. You know, the one most quoted, the one that you have to, like, every action has an equal and opposite reaction. This would violate that, because you have no rocket exhaust to propel you. You're just going, you know? Which relates to Arthur C. Clarke's book, Rendezvous with Rama, because basically this massive spaceship, Rama, is in the solar system, and they basically study it for a period of time and then leave. And at the end of the book, the rocket just goes. It just leaves the solar system. It says, I'm gonna head out, and it just travels without any exhaust. It just accelerates, which is just, you know, physics cannot reconcile that, you know?
Yeah.
But yeah, reactionless drives would be helpful in our FTL transportation that we were talking about earlier, is that transportation is very energy intensive, especially if you're trying to go anywhere near light speed. Of course, our warp drives and, like, teleportation and wormholes kind of offer, like, cheats, But if you're trying to go to like near light speed under modern physics, that's just a lot of energy you're using. And if you can have a reactionless drive, then you don't need to use all that energy.
Yeah.
Yeah. So anything else to add?
I would definitely recommend this book.
Oh yeah, it's a good book. Yeah.
It is a very good book, but I think that's a pretty good overview of what they are. And like I said earlier, it's interesting to see which technology leads to other technologies. And if we have these reactionless drives, then we would be able to produce more technology that's like based on energy, and that technology relying off that energy would just become advanced that much quicker.
Yeah. Yeah. So I'll move on to the next thermodynamics breaker. You have perpetual motion machines.
Yes.
Yeah. Do you want to start off this slide or?
Sure.
Cool.
So as you can see on the screen before you in this GIF, as it's pronounced.
Yeah, we got to mention that at least once per stream. Yeah.
Oh, we should also show them my new background.
Oh yeah.
Yeah, we can do that later.
Yeah.
So as you can tell from the GIF in front of you, a perpetual motion machine is exactly what it sounds like. It's a machine that is always in motion. It sustains its own motion, and using this type of machine could create a infinite source of energy, because it's always creating this kinetic energy that could then be converted into any other form of that energy that we need.
Mm-hmm.
But the only issue is that this kind of machine currently is impossible, because some energy is always lost, obviously not destroyed, but always lost in the process of doing this.
Yeah, just lost to the air and stuff, you know.
Yeah, due to air friction, air resistance, and many other factors. And simply the collection of the energy itself, like the transmitting of that energy, also causes a very small fraction of that energy to be lost.
Yeah.
So currently, this type of technology, like pretty much the rest of the technologies in this live stream, is impossible. But this type of machine could be the precursor for everything else that we've talked about.
Yeah.
Like with teleportation, with wormholes, with the warp drive. These could all potentially be powered by perpetual motion machines.
Yeah. Yeah, also, quick disclaimer, don't try to build the contraption that is, like, shown in this GIF. All you'll get is disappointment and sadness. If you try to make this machine and let it spin for a bit, it'll just slow down, because no perpetual motion machine has been created. Everyone that has tried to create one has either been like a charlatan or just, you know, someone that has wanted to make one but couldn't. So you've got some conceptual ideas like this, but if you actually like look into them, these ideas do not work. But yeah, so perpetual motion allows you to have unlimited energy, which is really interesting because it also allows you to have unlimited mass, because mass equals energy, E equals mc squared, right? And now it's hard to think that just an object that can keep itself spinning forever while producing some energy could translate into mass, right? Like, that is just such a foreign possibility, but it is true. Using energy, we can create matter-antimatter particle pairs, so a proton and an antiproton, or an electron and an anti-electron, and they quickly annihilate to form more energy. But if you could like get rid of the antimatter, just like safely get rid of it, then you can use the matter for other purposes. And one way that you might get rid of the antimatter is you could just chuck it into a black hole, because once something enters a black hole, it forgets what it used to be, and it just becomes mass and energy. So yeah, perpetual motion machines would not only allow you to have infinite energy, but infinite mass as well, which is really interesting. Yeah. Yeah. Like you could, like basically people have mass, right? So the mass of the universe is kind of the limit of how many people you could have, whether they are like actual biological people or people who have their brains stored on computers. You have this limit, which is your mass. If you can't create any more mass, then you have like a hard limit and you can't make any more people. But if you have a perpetual motion machine and can use the energy off that machine to create matter, then you could have like more people, you know?
Yeah.
Yeah. Anything else to add?
The perpetual motion machines, like I said, is going to be the precursor for everything else to come after it. Once we master this technology, then like instantly everything after it becomes that much more attainable. So kind of what we did in the last stream, where we did a timeline of the future, the creation of this kind of technology would help us place the date of the technology to follow after it.
Yeah.
When right now, in our position, we can't come up with the dates of any of these.
Yeah, exactly. Yeah, like it's kind of like the nuclear fusion of impossible sources of energy, because this would just allow you to power everything. It would be an instant end to like the climate crisis, because you would just not need oil because you would have your perpetual motion. So yeah, very interesting technology. Very interesting effects on society as well. Yeah, should I go to the next slide?
Yeah.
Okay, next slide. Entropy reversal. So we've got this nice GIF here of a glass of water unfreezing and forming ice cubes. So yeah, entropy, it's a law of thermodynamics in this universe that in any closed system, entropy always rises. But what if it didn't have to do that? So what this would allow is basically the way that energy works is that for energy to be useful, there needs to be a difference in energy. So this is basically goes back into where does energy go once you use it? Because we know that energy can't be created or destroyed. So why can't I just, like, the energy that I'm using, like, that's draining the battery of my computer right now, where does it go? And why can't I just reuse it instead of having to plug it into the wall, you know? And the answer to that is that it just kind of disperses, and it just kind of goes into the air usually. So this GIF is really just a video that has been reversed, like, obviously. But so if you think about the video in normal motion where ice melts to form water, you can think that the air is like 72 degrees Fahrenheit and the water is 32 degrees Fahrenheit, right? So slowly the heat from the air is like soaks into the ice and turns it into water, and then the room is slightly colder and the glass of water becomes room temperature, and everything is evened out, and now there's no difference in energy because they're the same temperature. So there's no longer any usable energy. And that's the problem with entropy, basically. Because if you think of the heat death of the universe, at that point in time, all the energy will be spread out evenly, which you don't want, because then, like, what could you even do? Like, you need energy differentials to compel anything to happen. Like, if you think of a classic, like, the way we generate electricity with, say, fossil fuels, it's basically you heat up the fossil fuels, right, like the oil, say, and that heat is transferred into water, which becomes steam that turns a turbine, and bam, you have energy. But now that heat kind of disperses into the atmosphere and makes things a bit hotter, which isn't the main cause of global warming. It's the carbon dioxide that's added. It's not really the heat from the burning reaction, it's the gas. But basically, the way that we make energy, the way that we use energy, is just always causing entropy to increase. So if you could make it decrease, then you would have pretty much an unlimited energy source, because whenever you used energy on something, you could just reclaim it and do that process again. So, like, do you have anything on this topic?
Just like the other one, it's really the precursor, and it's
Yeah.
just going to hold up all the other technologies that come after it. So
Yeah.
it's equally as important.
Yeah. Yeah, very true. So one possible way that entropy reversal might happen is if previously we talked about time travel, and so since the universe is a closed system as far as we know, the law of thermodynamics that entropy always increases applies to the universe itself. So if you had time travel, then you could just go back in time to when the universe was younger, right? Collect up, like, I don't know how time travel would work. Say you could open a portal to the past, or you could collect up a box, like a container of like the past, and bring it back. You would basically just get a ton of high energy dense material, and that would create an energy differential that you could use to continue powering devices, because the Big Bang was very, very hot. So if you went back in time to, say, like 100,000 years after the Big Bang, when everything cooled down enough that you could like do some stuff like to actually collect the energy instead of just like dying, then you could just open a portal up to 100,000 years in the past, let a little of the past like out into the future, and then use it for energy and close up your portal. And then whenever you were just out of energy and like entropy was a bit too high, just open up another portal and then close it. So yeah, entropy reversal is very similar to perpetual motion machines in that it allows you to get more usable energy. So yeah, now we're going to go to our next topic, but first we will check the chat. Oh, no developments. Still 2 concurrent viewers. Thank you for hanging on.
No problem.
Yeah. So, anyways, we'll continue. So we've got anti-gravity. Now, anti-gravity.
Go ahead.
This isn't really an apt name for this topic. I wanted to call it like mass manipulation, but there's also like the concept of mass manipulation, which is like social like conspiracy theory stuff. But this is basically toying with the property of mass, that all everything in the universe, like all matter, has mass. And if you can mess with this property of matter, then you get a lot of interesting results. So yeah, you were gonna say something?
I was just gonna give a brief overview of that. Gravity is one of the 4 main forces in the universe, alongside electromagnetism, strong force, and weak force. Strong and weak nuclear force.
Mm-hmm.
And it's the weakest out of those forces. It's weaker than weak force.
Yeah. Yeah, I know, the naming is so bad.
Which sometimes humorous.
Yeah.
But we're always fighting gravity, like whenever we're not on the core of the Earth, because that's where the gravity comes from.
Yeah.
So using or creating anti-gravity devices it's probably one of the most realistic or closest technologies in this entire live stream, because there's already a lot of research into this, obviously, with space shuttles like taking off and escaping Earth's atmosphere, and all of that, but also because gravity is very easy to like resist, but
Mm-hmm.
the difficult part comes from like almost like going completely against it
Yeah.
and having, like you see before you, a 1 kilogram bar
Yeah.
floating or
Yeah.
just ascending.
Yeah. Yeah, it's really interesting, especially with the discovery of the Higgs boson, which gives particles mass. If you could come up with some sort of process that's like removes the Higgs boson from certain particles, then that would effectively be anti-gravity. This device specifically, it's magnetic levitation. It's using a superconductor, a cold superconductor, to levitate objects. You may have seen. Have you seen videos of this? It's pretty cool. It uses like these magnets to just float objects. But it isn't anti-gravity. It's just using electromagnetism to counter gravity. But yeah, it's really cool. It actually reminds me of another topic that we didn't really put in, but it's the concept of a hot superconductor, which is basically superconductors are like materials that conduct electricity extremely well, but they only work when they're very cold, like very cold. Not even liquid nitrogen is able to like make them cold enough. You need liquid helium, not liquid hydrogen. That would probably cause it to explode. You need liquid helium. And yeah, liquid helium makes things cold enough. Like they use it in MRIs and particle colliders. But if you could find a hot superconductor, and when people say hot superconductor, the temperature of liquid nitrogen is considered hot, which is pretty crazy, you know? But it would greatly make everything like MRI and particle colliders, it would make it so much cheaper, and you would get rid of the helium concern because we're losing helium. But yeah, that's for another time though. But it's interesting. So yeah, so we'll go to the first kind of anti-gravity. We've got susceptibility to gravity. So this is basically just this is just typical objects fall to the ground because of gravity. But if you could like cancel an object's susceptibility to gravity, then when you dropped it, it could just stay there, float there, you know? So this would allow you to, say, get to orbit very easily, because if you had a process that could just turn off an object's gravity, then you could just turn off gravity, let the object float up for a bit, and then turn it back on again, and bam, it's in orbit. Providing that you give it tangential velocity, then it'll be in orbit. Otherwise, it'll just fall back down. But yeah. Do you have anything to say about this?
Basically what I was saying in the beginning, and obviously going off of what you said, this is, again, going to be super useful in so many different facets. Like, obviously, like, if for construction, like, if you had
totally.
a portable anti-gravity device, you wouldn't need a massive crane to lift one bar of an entire building.
Yeah,
you
also
just set up this, and
also you could even like make buildings less massive so that they don't have like architectural constraints, right? So that they don't like fall down, you know?
Yeah.
Like you can make a really tall building and like give it 1/10 mass, like gravitational mass, and then it'll be like good, you know? You could use less support. But anyways, go on.
It can be used for that, and even like in extreme cases, it can be used to like possibly even like suspend things indefinitely over the ground.
Yeah.
And these anti-gravity machines would have to be powered by perpetual motion machines, which would give them the energy they need to sustain whatever object like hovering in midair.
Yeah.
So again, this shows like what leads to what, because if like say there's some construction where the easiest way to do it is to do it in like a zero gravity environment, which is true of some apparatuses that need to be built. If this is powered by the perpetual motion machines, and the anti-gravity machines contribute to the production of the other technology. Again, it's just that ladder of events occurring.
Yeah, yeah, and it also adds the possibility of like living on other planets, right? Say the planet Jupiter, the gravity there is like 2.5 times higher than on Earth, and that is like not comfortable for people, like causes health problems, blah blah blah. Like
Yeah.
you couldn't do it, you know, you couldn't live there. But if you, and I mean, it doesn't have a solid surface, but say that you had blimps, like floating cities, like you might do for Venus. Say you had that on Jupiter, you would still have the problem of there being too high gravity. So if you just had, whenever anyone arrived to Jupiter, they just had their like anti-gravity generator on, like 60% capacity, say, and their mass was reduced by 60%, then they would only be experiencing 40% of Jupiter's gravity, which would be Earth level gravity, and they would just be A-OK. And if you could say increase susceptibility to gravity, then you could live on the moon where there's too little gravity and be like pulled down more. That's like a possible like use of like gravity manipulation, you know?
Yeah.
Um,
Do you want to go to the next slide?
Let's see. I think I wanted to say one more thing. I can't remember though. Oh yeah, I was gonna say you could also have like wacky like hijinks. Like if you think of like societal aspects, you could have like, you know, some sort of villain, like I don't know, like villain type that has like a gravity increase gun, and it's like maybe it's like a mobster guy, right? And he like increases your gravity, and then you're like pinned to the ground, and it's like hard to breathe, and then they're like trying to get information out of you, right? Or they just like turn off gravity, and it's like you're gonna float away, and it's like, oh no. So yeah, you could have interesting cases.
Maybe that supervillain could have some name involving like gravity.
Yeah.
Maybe that supervillain could be named Gravity Max.
Oh god.
No. He takes gravity up to the max.
Oh no. You figured out my secret.
It was you all along.
Yeah. Yeah, but anyways, yeah, you would have interesting criminal cases with people misusing this ability to manipulate gravity. And you could even have some like shady government stuff where they use quote unquote enhanced interrogation methods involving yeah, exactly, like yeah, like things that are like the ethics aren't looking very good for the ethics. There could be some unethical uses of susceptibility to gravity. But yeah, it's just another societal concern, you know?
Yeah.
But yeah, so I'll go to the next slide. So this is pretty much the inverse of the last topic. This is an object's gravitational pull, right? So say this water bottle that I have on my desk next to me. It weighs, well, it's like 500 milliliters of water. It's like half full, so it weighs 250 grams, right? Because the density of water is such like that. But what if it just like weighed more but didn't actually weigh more, that it was heavy in my hand, but weighed more, that it had more of a gravitational pull, say of an object with like 250 like million kilograms, right? Then you could end up having like a gravitational pull towards this object, even though it isn't that massive. And you could have this sort of gravitational pull towards it that you would expect from a massive object. And so a way that you could use this is on planets and small worlds, like say an asteroid, right? If you want, like, if some people want to build a town on an asteroid, but the gravity is way too low. You could just ramp up that gravity by a factor of 1,000 for that asteroid, and then they could have Earth-level surface gravity. You could also, say, decrease an object's gravity, like with Jupiter, but the difference here is that by manipulating gravitational pull, it would be significantly harder than manipulating susceptibility to gravity because, as you can imagine, it would be a lot harder to decrease the entire planet of Jupiter's gravitational pull than it would be to just make people less massive, less susceptible to gravity, you know?
Yeah.
Yeah. So here you also have some sort of societal, unethical, like, crazy schemes that could come up where, like, someone makes, like, a gravity bomb or something where it's just, like, a small, like, sphere, right? Just, like, you know, like, the pumpkin bombs from, like, Spider-Man, like, those weird,
Yeah,
like...
the green gun.
Yeah. You could just... You throw one of those, and then it just, like, creates a black hole or something, or just some really strong gravitational field that people are pulled towards, and that would just be a problem. But it could also be used in, like, warfare and things like that. Yeah. What do you think about this?
Well, this I can't help but think back to Half-Life,
Uh-huh.
where they have the gravity gun.
Yeah.
But yeah, no, you're right. Controlling gravity, like in and of itself, would just be a platform for other technologies to come out of it, like the gravity gun from like Half-Life or something like that,
Yeah.
which can like lift incredibly heavy things using just the force of gravity and like anti-gravity, like reversing it.
Yeah.
But if we use gravity in, say, construction or anything like that, we could like realistically get closer to things such as Dyson spheres.
Yeah, true.
Or which we talked about in our last live stream.
Yeah.
For you who didn't watch it. We could use this gravitational technology to just further advance different things and get ourselves used to operating in a zero gravity environment such as space.
Yeah.
Because colonizing certain planets would require large structures built in outer space around that planet.
Uh-huh.
And I think that this kind of technology just helps in that aspect.
Yeah, totally. Should I move on to the next slide?
Yeah, go ahead.
Okay. So this is the last manipulation of mass, and it's kind of like the oddball from the rest. It is inertia negation, or you could also increase inertia. But basically what this is if you watched Bill Nye in school when you were younger, you would have heard inertia is a property of matter many, many times.
Science rules.
Yeah. And basically inertia is inertia is the m in F equals ma. Like, inertia is an object's mass relative to the forces that are being put on it, like the pushes and the pulls that are being put on it, like not gravity per se, but like say you can like push an object across a desk, right? But if you have negated that object's inertia and it just has no inertia, then you could like tap it and it would just like zoom across, like it could go crazy.
Yeah.
And you could also increase an object's inertia and just make it so that it will not move at all, just not budge, which would be interesting too. So basically, inertia negation would likely be used in space travel because, as I said for reactionless drives, space travel is very energy intensive and requires a lot of force to move the mass a certain distance. So if you could decrease an object's inertia, basically decreasing its mass for these equations, you would end up having the ability to, say, like move a huge spaceship that has like the mass of like a tanker ship, right? You could like negate its inertia to the point that it only weighs like a kilogram. And when the amount of force that you would use to like accelerate a kilogram is the amount of force that you could use on this rocket ship and just send it off really fast.
Yeah.
It would also be interesting to have like negative inertia and like negative mass for these different things, because it would be like if you pushed an object and instead of like going, it just pushed back on you and like began going in the other direction. And that's the same for the gravity and susceptibility to gravity too. If you could have negative mass in those situations, like if you had a negative gravitational pull, say, like for the last slide, then you would be able to create a perpetual motion machine, because like you could have one object with a positive gravitational pull and one with a negative gravitational pull, and the positive object would pull the negative object towards it, right? But then the negative object would push the positive object away, and they would just kind of accelerate off into the distance forever, like a Minecraft sticky piston machine. It would be like that. That could just go forever. So you've got some really interesting cases here with when you mess with mass, it just creates a lot of interesting problems. And inertia negation, since I came up with like societal situations for the last two, I kind of feel obliged to come up with one for this. You could have issues where like someone someone like that's just angry and just wants to piss people off could just like stop their car on the road, or maybe not their car, just a like junker car or something, and just give it like 1,000,000 times inertia and make it impossible to move and just cause a huge traffic jam, right?
Yeah.
Like that would be an issue. You could also have like the decrease of inertia could be used in different situations. What do you think?
Yeah, this, just like the other ones, would be such a massive boon to the economy.
Yeah.
Obviously, because anything that can be done faster, it's in everyone's best interest to pursue that, which then helps economics everywhere.
Yeah.
It's also interesting to see, I talked about this a lot in our last stream, where when this new technology is put out there, you start to see a race from different companies and then eventually different countries to get their hands on this technology.
Yeah.
So when this stuff would start coming out, this mass manipulation technology, now I'm hesitant to say that.
Yeah.
But that kind of technology, it'd be very intriguing to see who pursues that. Like, not only which countries, but which companies. Like, realistically, there could be, like, the Google Gravity, or, like, Amazon Inertia Negation Plus, or whatever.
Yeah.
And I just think that...
Amazon Prime Instant Inertia Negation.
Yeah. Apple Airplane Mode.
Oh, gosh. Yeah.
But, I think it's just a very, like, for us it'd be comedic, but this could be a reality. Like,
yeah, exactly.
In our last live stream, we talked about the contact lenses that, like, were basically computers in your eyes, and the companies that were pursuing those were Google, Sony, and Amazon, right?
Yeah.
Yeah. So it's these consumer-based companies that are actually helping lead the technological effort forward.
Yeah.
So that's what I have to say about that.
Cool. Yeah. So that's it for this section. So I'm just gonna check the chat again. We have another person says hello, and now we have 3 concurrent viewers. So we have 3 people watching.
You better say bless you.
Oh, let's see. It'll take a second. It'll take a second because it's on 30-second delay. So
yeah, I know.
It'll take a second to see that. But
our third viewer better say bless you.
Yeah. Let's see. I think it's coming up. in the stream. I just kind of wait. I kind of want to wait here for a second to see if it comes up in the chat. If they, yeah, I just want to see if it happens. Let's see.
Yes, that's Alright, I just sneezed.
Okay, let's see if it happens.
It says hello, and now we have 3 different viewers. So we have 3 people watching. Let's see. It'll take a second. It'll take a second because it's on 30 seconds delay. He's not saying it.
Oh my gosh. Okay. Well, I guess we'll have to move on. Thank you for watching.
This is a true tragedy.
This is a tragedy. Thank you for watching. Anyways, but yeah. Okay. I guess we'll.
Oh, he said this is.
Okay. Message retracted. Okay. I guess we'll go on.
You better say bless you. Oh.
Okay. I'm just gonna move on. You can.
Moving back to what we're doing.
Okay, yeah. So the next topic, probability manipulation. So this is a scene from Deadpool 2, where this character basically, she describes that she has the superpower of being lucky, and like Deadpool and the other characters, they kind of scoff at that, like, how is that a power, just being lucky? But the ability to manipulate probability would be hugely useful in the future. Do you have anything to say about it?
Yeah, I think this is interesting because the late Stan Lee said that if he was to have any superpower, like he was often asked this question.
Uh-huh.
The question was, if he could have any superpower, what would it be?
Mm-hmm.
And he always said that luck was the best superpower.
Huh.
You know?
Yeah.
And it's interesting coming from a guy that's created so many of the heroes we love today, like Spider-Man, namely, and Iron Man, and all of those guys. And he believed that luck was the best, most powerful superpower. And I do agree with him. Because if you can manipulate the probability of things happening, you can control the future.
Mm-hmm.
You know?
Yeah. Yeah. I'm gonna go to the next slide, but it's still talking about the same thing. Quantum mechanics, it's basically a way... quantum mechanics is like the randomness in the microscopic, like subatomic level, but further investigations of quantum mechanics might be what lead to macroscopic probability manipulation. Yeah. So I guess I'll talk about the like the effects of probability manipulation on society. First off,
He said, bless you. Let's go.
He did? Oh my gosh, I have to check this. Nice. Great. Anyways, yeah, so do you want to say anything about quantum mechanics? Then I'm going to discuss, I'm going to discuss the, like, effects of probability manipulation after, but, yeah, talk about, like, how quantum mechanics might allow you to have probability manipulation.
Okay. So, I went to Yale, as I like to boast, for 3 weeks to do some additional studies and live on the Yale campus. And one of the things I heavily studied and took classes for was quantum mechanics. So, what you see in front of you, and it says hydrogen wave function underneath the probability density plots, a large amount, well, first of all, let's take a step back. Quantum mechanics is the physics of the incredibly small, of subatomic particles and how they behave. And one of the reasons that physics, as we mentioned way earlier, as physics doesn't have a unifying theory, is because this science, quantum mechanics, doesn't agree with the science of general relativity concerning gravity. Gravity is one of the main things stopping a unifying theory from coming into fruition. So quantum mechanics is the study of the incredibly small, and honestly, if you see in any kind of like media or any kind of movies how when they have some super scientific technology that they don't want to really explain, they always just put quantum in front of something.
That's
like
true.
The quantum carburetor
or quantum carb. Yeah, honestly, like
that.
when you add the word quantum, it makes it so that an actual explanation would be just as confusing as not saying anything at all.
Because the point, or one of the things about quantum mechanics is that things happen almost irrationally. And well, it seems to be irrational, and which leads many to believe that there's an outside force that we don't know about.
Mm-hmm.
But what you see in front of you right now is, and that equation up there is used to determine the probability of a particle, usually an electron, of a particle being in any given spot. And usually what they would do is they would draw up a plot kind of like this. There's different representations of it, but they would draw up something like this, and they would most likely do it to three places. They would say this is the most likely place for this electron to be, and this is second most likely, and this is third most likely.
Mm-hmm.
But it's that uncertainty about it that kind of makes many scientists and physicists stay away from quantum mechanics.
Yeah.
Because as Albert Einstein described one of the aspects of quantum mechanics, he said it was spooky action. And the reason he called it spooky action is because it realistically can't be explained from the information we have now. And he said that all the way back in his age. But still to this day, we don't really understand why it is what it is.
Yeah.
But the thing is that we use probability to determine what it most likely is.
Yeah.
And there are many equations for this. The one in front of you, I think, was created by Erwin Schrödinger, one of the most famous physicists, and he contributed quite a lot to quantum mechanics.
Yeah, definitely. It's funny. He like contributed a lot to quantum mechanics, but he got just like so weirded out by quantum mechanics that after a while he just went back to biology.
Yeah.
Like he's also famous for the Schrodinger's cat thought experiment.
Yes, which is an experiment in something called superposition, which I actually have an entire presentation on, which I gave at Yale.
Yeah, we'll do that for next time.
Yeah.
We'll talk about quantum mechanics more for next time, but it's basically like the probabilities and the randomness. If you could figure out a way to, like, I don't know, mess with those, you could change things on a macroscopic scale, right?
Yeah.
So that would be how you do probability manipulation. So the effects on society, right? You would basically, Las Vegas would shut down. I mean, because if you could easily just, change things so that, like, your die will roll like whatever number every time. I don't really know how a lot of the games works. I just know how to play, like, blackjack and war. But like, if you could change the probability of things, like gambling would just be dead. Maybe for the better, honestly. But because you couldn't sustain any sort of, like, how they say the house always wins. You couldn't sustain any sort of, like, gambling system because if anyone had a probability manipulator, they could just game the system. And you would have to shut down. Unless you can figure out a way, like a sort of like a metal detector or something where, like, it figures out, hey, you have this device on you, you're not allowed to enter if you have this device. Something like that. But, so that's probably the first effect. It would have a lot of negative impacts on gambling as an industry, which would probably have positive impacts on society. Also, interesting aspect is that you could cause like mass devastation with probability manipulation. Um, like
Yeah.
countries would definitely have to like defend against it, like at airports and stuff. If you had a probability manipulator that caused like the low probability of event of like a bird flying into your plane's engine, um, then you could like crash a plane using probability manipulation, which would be like, obviously a concern of the government and the TSA, because you wouldn't want that to happen. But on a less like catastrophic and like negative note, you could have like a sort of like weak like good luck field on your entire house. So like a weak good luck field that kind of made it so that like if your arm bumped into like a mug of coffee or something, it wouldn't fall off the desk. It would like slide right to the end and then stop, and you'd be like, "Oh, haha, good thing I have my like good luck generator." Or I guess it would be a good luck charm, like one that actually worked. It would be a real good luck charm, but it would just be a machine. So yeah, you could make it so that like you won't ever stub your toe. You could prevent like injuries and accidents with probability manipulation. Like it might, if you ever, like if we ever invent a machine that is able to manipulate probability and it's small enough and portable enough, it might become like a requirement to put it in your car. Like it might be a requirement that all cars need to have probability manipulators in them to prevent car crashes, because like luck could just make it so that like you could just take your hands off the steering wheel, and even if it's not a self-driving car, it just like won't crash at all if you have strong enough good luck.
Yeah.
Do you have any ideas, like any societal impacts that you could think of?
Well, with quantum mechanics, if we like build technology based off of it, which is the subject of another one of my presentations, which I'll give next stream. If we build technology off of it, specifically, and I go into this, the quantum computer. The quantum computer can perform like an incredible amount of functions like per second. It'll basically like it's basically a supercomputer.
Yeah.
That's so incredibly strong that it can hold like all the data you'll ever create in your life. And that can be used for like major databases and other things, and that runs on actual quantum mechanics. And I'll get into that next stream, how that actually works.
Yeah.
But,
yeah.
Other than that, I think it serves more of a I can't think of a good word for it right now, but I think it's very important to just our understanding of the universe as like humans living in it.
Yeah.
If we can like master this spooky action as it's been described, if we can, the more we figure out about the universe, however small like quantum mechanics or however large like gravity, to whatever scale, whatever we find out about the universe just helps us figure out like our place in it more and more.
Yeah.
And it helps us, understand why we're here in the first place.
Yeah.
And it might not give us a purpose, but it might as well give us an explanation.
Yeah, that's true. Yeah, so all of these, I think I'll go to the final thoughts slide.
Yeah.
So, yeah, all of these technologies might not ever happen, right? Like, it might be that none of these ever occur just because it might be that physics isn't like that. If you think of our, like, sphere of knowledge as, like a circle, right? That circle has blurry edges. And towards those edges, as you, like, go to the frontiers of physics, the questions there, the like yes or no answers that you can find will kill or allow for all of these technologies. So it's really interesting as we discover more and just figure out more about physics. more of these technologies might be eliminated, like, and known definitely like not possible, or they might be like added and figured out and like used in the ways that we mentioned in this video. Yeah. So yeah.
My final thoughts on this is that, like I said, one thing's going to lead to another.
Yeah.
And I think this coincides well with our last stream, and I think it helps paint a better picture of the future.
Yeah.
And we can't really tell you when in time that future will be, but if we master time travel, then hopefully someone will come back for us.
Yeah.
And hopefully we live in a multiverse, so when they do come back for us, they will rip the universe into shreds.
Yeah, exactly.
So, for what it's worth, I'm looking forward to this technology, even if it might destroy everything we know.
Yeah, even if it just completely changes everything. It would be really interesting if just one of these was possible. Huge impact if anything like this occurs. And I think just generally positive. The more technology, the better, in my opinion, generally, because even though they can have some negative consequences, they are mostly used for good. And yeah, I say mostly, but definitely you'll have some concerns along the way, and you'll want to make sure that things go well. So it's good to predict those concerns like early and think about, okay, we got to be careful with this. People might use it for this, this, and this. So we got to build up defenses to that. So yeah, next time we will be talking about quantum mechanics, really in depth. Like we'll have
a few presentations.
We'll use your presentations, and I'll add anything that I know. But I think you're probably more researched on that than I am. So that'll be.
That's rare. That is very rare.
Yeah.
I have more research on the topic than the great famed Gravity Max.
Yeah, I just gather a lot of background information. Basically, I just gather information like a sponge, and I just don't let go of it. So I just find out a random fact, and then I just keep it. So that's how we can generate like 2-hour-long conversations like these. Just two people that know a lot, just have a lot of background information on things. So that'll be for next week, same time, 7 p.m. Eastern time. And then the week after that, I think we might have another one of our friends on, another guest. I think we'll be talking to them about that. I think that's it. Let me check the chat and just end of stream chat. Okay, nothing new, but that's okay. We have 2 concurrent viewers right now. I think this went pretty well. Second stream, went pretty great.
Yeah, so I would like to thank everyone for your patronage in watching this video.
Yeah, thank you.
I wish you all a good morning, good afternoon, or good night, depending on where you are. And if time travel does become a thing, then I might see you at all of those times.
Yeah.
So this is Gravity signing off.
Yeah, thank you, Gravity. And this is Max saying thank you for watching, and see you next time.